Ever wondered how complex systems are designed and structured? Today, we're diving into the world of domain modeling in object-oriented analysis and design. At its core, domain modeling is about creating a structured visual representation of the significant entities within a problem domain and their relationships. It's a crucial step in system development because it helps developers, designers, and stakeholders communicate effectively. And how does it do this? By creating a model that identifies the key elements within a specific area of interest and reflecting these as classes that mirror real-world entities. But remember, it's more about understanding what the system is about rather than how it will accomplish its tasks. This conceptual model defines the structure of data within the system, without detailing the behavior or methods of managing that data. Are you ready to draw up the blueprint of a system? Let's delve into the steps of domain modeling. The first step in domain modeling involves identifying the key concepts or entities that are relevant to your problem domain. This step is your starting point, your foundation as you delve into the intricacies of domain modeling. It's all about understanding the problem domain and defining the significant objects within it. Let's imagine we're building a library system. You don't have to be a librarian to know that a library system is going to involve books, right? But that's not all. We also have the people who use the library. Let's call them patrons. The patrons borrow books, creating a loan. And of course, there's someone managing all these operations. Let's call them the librarian. So we've identified 4 key concepts: book, patron, loan, and librarian. These are the major players in our library system, the fundamental entities that will drive our domain model. Notably, these concepts represent real-world entities, not abstract ideas or behaviors. Remember, the goal here is not to model every tiny aspect of the domain, but to focus on the significant entities and their interactions. It's not about getting lost in the weeds, but about creating a clear, high-level snapshot of the domain. As you can see, identifying domain concepts is a crucial first step in domain modeling. It sets the stage for the rest of the process, providing a solid baseline for defining attributes, establishing relationships, and more. Having identified the key concepts, we can now define the attributes for each concept. With our key concepts in place, we now need to determine the information that needs to be tracked about each concept. So, how do we do that? Well, we delve into each concept and identify the characteristics or properties that are essential to it. These characteristics become the attributes of our classes in the domain model. In essence, these attributes are the bits of information that we want to track about each concept. Let's continue with our library system example. One of the key concepts we identified was a book. Now, what information would we want to keep track of for each book? We might want to know the title, the author, the ISBN, and the publication year. These become the attributes for our book entity. Similarly, for the patron entity, we might want to track their name, library card number, and contact details. For the loan entity, attributes could include the loan date, return date, and whether the loan has been returned on time. Remember, the attributes you choose should be relevant and necessary for the system you're designing. They should provide a clear and comprehensive picture of each concept. Now, you might be wondering what's next after defining attributes. Well, we have our entities and we know what information we want to track about them. The next step is to connect the dots and establish relationships between these entities. Now that we have defined our attributes, we can establish relationships between these concepts. Identifying the relationships between the entities is our next step. In our domain model, we're not just concerned with the individual entities, but also how they interact with each other. This is where the real magic of domain modeling comes in. Let's continue with our library system example. We have our key entities: book, patron, loan, and librarian. Now we need to figure out how these entities relate to one another. These relationships are not arbitrary but reflect the realities of our library system. A patron, for instance, can have multiple loans. This is a one-to-many relationship. On the flip side of that relationship, a loan is associated with exactly one book. That's a one-to-one relationship. And just like that, we're beginning to see how these entities interact in the real world. But we're not done yet. It's not enough to just identify these relationships. We also have to characterize them. This is where we talk about multiplicity. Multiplicity is all about quantities. It tells us how many instances of one entity can be associated with instances of another entity. In our library system, for instance, we might say that one patron can have 0 to many loans. This is a way of saying that a patron might not have any loans, or they might have several. It's a flexible relationship that reflects the realities of our library system. With relationships established, we can now identify inheritances and generalizations. These will help us further refine our model and make it even more reflective of the real world. But more on that in the next scene. Inheritance and generalization play a key role in structuring our model and reducing redundancy. It's like creating a family tree for our entities. By identifying these relationships, we can create more efficient and clearer models. Let's continue with our library system example. Imagine we have a class called employee. In our library system, there are different types of employees such as librarian and administrator. These subclasses share some common attributes with the employee class, like employee ID, name, and contact information. However, they also have unique attributes. For instance, librarian might have area of expertise, while administrator could have admin level. In this case, employee is a generalization of librarian and administrator. This means that librarian and administrator inherit the attributes of employee, but also have their own specific attributes. This relationship is a classic example of inheritance and generalization in action. Identifying these relationships helps us reduce redundancy in our model by not repeating common attributes in each subclass. This makes our model easier to understand and manage. It also allows us to leverage the power of object-oriented programming, where subclasses can inherit properties and methods from their parent classes. In the next step, we will be looking at how relationships can become entities in their own right, leading to the creation of association classes. Lastly, we will create association classes if necessary. Our final step in domain modeling is to create association classes if necessary. As we know, our domain model is gradually taking shape, with concepts, attributes, relationships, and inheritances all defined. However, we sometimes stumble upon relationships that are so significant, they qualify as entities in their own right. These are what we call association classes. Picture a relationship with its own set of attributes. For instance, in our library system, we have a loan relationship between book and patron. But this loan isn't just a connection, it comes with its own data, the loan date and return date. In such scenarios, we model this relationship as an association class. An association class is like a bridge that connects two classes, carrying its own baggage of attributes. It allows us to capture more intricate details within our system, highlighting the complexities of real-world interactions. Creating association classes is not always necessary. It's a step we undertake when a relationship is more than just a link and holds valuable information that needs to be encapsulated. It's about looking at the bigger picture and understanding the nuances of the system we're modeling. To conclude our library system example, we've now identified our concepts, defined their attributes, established relationships, identified inheritances, and created association classes. We've crafted a domain model that provides a clear, structured representation of our library system. And there you have it, the steps to domain modeling. So, we've journeyed through the steps of domain modeling. Let's take a quick jaunt down memory lane. We began by identifying key concepts within our domain. For our library system, this meant recognizing entities like book, patron, loan, and librarian. Then we defined attributes for each concept, such as a book's title and author. After that, we charted the relationships between these concepts. We saw how a patron could have many loans, but each loan corresponded to just one book. We also discovered that some concepts, like employee, could be generalized into more specific classes, such as librarian or administrator. And finally, we created association classes when necessary. Remember our loan class? It turned out to be an association between a book and a patron, carrying its own attributes like loan date and return date. This meticulous process of domain modeling gives us a shared language, a foundation for further design, and perhaps most importantly, it simplifies the complexity of the system. There are handy tools out there that can support this process, like Enterprise Architect, Visual Paradigm, and Star UML. These tools help us visualize our domain model, making it more manageable and comprehensible. Next time you're faced with a complex system, remember the steps of domain modeling and how it can simplify the process. Until next time, happy modeling!